Hi everyone, today we're going to be talking about stoichiometry and the mole. First of all, let's talk about the mole. I'm sure at this point many of you have heard of the mole. So what exactly is the mole? For this example, I'm going to refer to a concept which I'm sure you've heard of, the dozen. How much is a dozen? 12, right? No matter what object you have, a dozen is always 12. If you have a dozen eggs, it may weigh more than a dozen feathers, but they are both still a dozen, right? Moles are the same way. The reason we use the mole is because it simplifies how compounds react. We can take the mole, the central unit of chemistry, and from here convert to mass, volume, and even the exact number of particles. First of all, let's talk about the number of particles. For this, we use Avogadro's number. 1 mole of any compound or element is equal to 6.022 times 10 to the 23rd particles. For example, a mole of oxygen molecules, O2, is that number of molecules. But be careful, because if they ask you for the number of atoms in a gas such as oxygen, you'd have to double Avogadro's number, because for every molecule of O2, there are 2 oxygen atoms. Now, let's talk about volume. This one is just for gases, and specifically only if they are at room temperature, which is 25 degrees Celsius, and 1 atmosphere of pressure. And the question will tell you this if they ask you. All gases, when at these conditions, have a conversion rate of 1 mole to 22.4 liters. That means that oxygen gas under these conditions, 1 mole of oxygen gas is 22.4 liters. 1 mole of nitrogen gas is 22.4 liters. And it's for all gases at this standard temperature and pressure, or STP. Finally, you have mass, the most complicated one. We talked about average atomic mass before, the numbers with the decimals in the periodic table. This is also known as molar mass. For each atom, 1 mole of these atoms is equal to that average atomic mass. What about compounds? To find the molar mass of compounds, you just add the individual masses of each atom in the compound up. Going back to our example of oxygen, or O2, 1 O2 molecule contains 2 oxygen molecules. So you would do 16 plus 16, because that's the atomic weight of oxygen, and you would find that the molar mass of oxygen is just 32 grams per mole. Now that we've learned conversion factors, what exactly can moles be used for? Let's look at a basic chemical equation for the formation of water. 2H2 plus O2 makes 2H2O. These coefficients, don't forget about the implied 1 in front of the oxygen, are also known as mole ratios. For example, for every 2 moles of hydrogen that react, 1 mole of oxygen will react. We know this because of the coefficients. There's a 2 in front of hydrogen and an implied 1 instead of oxygen. This always applies, no exceptions, which is why it's super important that you balance reactions. You can use that with molar masses and say that for every 4-ish grams of H2, because that's 2 times the molar mass of H2 that react, 32 grams of oxygen will react, because that's 1 time the molar mass of oxygen. This is why, again, you must balance every reaction with the correct coefficients. The mole is an extremely important concept that you must understand. Now, we are going to transition into a more math-based part of chemistry, stoichiometry. Stoichiometry is basically converting between substances to find the amounts needed to complete reactions or to predict how much product you'll get from a reaction. The best way to get into this is to do some examples, so let's jump right in. This first example gives us a balanced reaction for, once again, the formation of water. We are told that we have 3.03 grams of hydrogen, and we are trying to figure out how much water that will make. Right here, I like to label each element with what we know about it, and by each element, that's either an element or a compound. For hydrogen, we know that we have 3.03 grams. We don't know anything about oxygen, but that doesn't matter, so we won't put anything there. For water, we are trying to figure out how many grams we have, so I'm going to put question mark grams. Now we know where we're going and we know what we have to start. So we need to use dimensional analysis. Always start with the given. We start with our 3.03 grams. Remember that we must convert to moles first before converting to another substance, because the mole ties the chemistry together. So how can we get from grams to moles? Because obviously we have to cancel out grams. By using the molar mass of hydrogen, by adding up 2 hydrogen atom weights, is 2.016 grams per mole. When we divide by that, we see we get moles and grams will cancel out. Next, we have moles of hydrogen, but we need to get to moles of water. To do this, we use our coefficients. Like I mentioned before, the coefficients of a balanced reaction always represent the amount of moles that will react. We know that for 2 moles of hydrogen, 2 moles of water are produced, so we put 2 moles of hydrogen on the bottom and 2 moles of water on top. Now, we go from moles to grams by multiplying the molar mass of water, 18.02 grams, to get our final answer, 27.08 grams of water. Here's a quick tip in case you were confused. Always look at what you're trying to cancel out, what comes before your dimensional analysis. For example, in the first example, we were talking about canceling out grams first. Then you have to look at where you're trying to go. We were trying to get to grams of water, but you always have to go through the mole. That's really all I have for you guys here today. Next week, we will be talking a little more about stoichiometry, including limiting reagents. I hope this video helped you guys, and I'll see you in the next one.